Hello, and welcome to this particular lesson, which is an introduction to motion for GCSE Combined Science in the AQA specification. So in today's lesson, we're going to focus on understanding what speed and velocity are and linking them to distance time graphs. So we're going to try and describe speed, velocity, distance and displacement, both using words and mathematically, understand how to interpret a distance time graph, and then retrieve information from looking at a distance time graph, which fits into the AQA Combined Science specification, which is in the forces topic of the physics section. So we're going to focus on the following parts of the GCSE specification: distance and displacement, speed, velocity, and the distance-time relationship. So speed is a quantity that's discussed a lot in everyday situations and applications. Now, it's not something which involves direction, so it's therefore a scalar quantity. Now, the speed of any moving object is very rarely constant. Now, in the example of humans, when people walk or they run or they travel in a car, their speed is constantly changing. Now, that can depend upon your age, the terrain to the ground that you're on, your fitness, or the total distance you've already travelled. Now, we do use speed a lot in everyday life. So we can say that someone's travelling at a high speed or that they move at a fast speed, but what does the word speed actually mean? Well, speed is a quantity measuring the distance an object will cover in a certain time. Now, there are different measurable speeds in the world. So, for example, the average walking speed for a human is typically 1.5 meters per second. The average running speed for a typical human is 3 meters per second. The average cycling speed for a human is about 6 meters per second. The speed of the average car is about 14 meters per second, and the speed of a plane is about 280 meters per second, and the speed of the Earth orbiting the Sun is about 30,000 meters per second. So hopefully with these values, you can get an understanding of what the typical values of speed are. Now, you've got to be able to remember the average walking, running and cycling speeds for your examination. Now, please do remember that speed does not involve a direction, so all these values are scalar quantities, and these are average speeds because the speeds of all objects rarely stay constant because of things in walking and cycling and running, things as age, terrain, fitness and distance travelled. Now, other types of speed can also vary as well. So, for example, the speed of sound and the speed of the wind will also vary. Now, the typical speed of sound in air is 330 meters per second, but the speed of sound varies on the density of the medium that you're traveling in, because the denser the medium, the closer the particles are together, so the faster the speed of the sound wave that can travel through it. So this means that sound will travel the fastest in the most dense medium, solids, and travel the slowest in the least dense medium, gases. So as a result, if you had a sound wave travelling through an iron bar or a sound wave travelling through air, it will travel through the iron bar faster because it's a denser medium. Now, with all these values, how do we calculate these speeds and what do we mean by the units meters per second? Now, we can calculate speed with the following equation. Speed equals distance travelled over time taken. Now, this equation you do need to know for your examination. You have to memorise it and you've got to be able to rearrange it. So you've also got to be able to make distance travelled the subject and time taken in seconds the subject as well. Now, you've also got to be able to work out the units for speed. Now, in everyday life, we can use kilometers per hour for speed or miles per hour for speed, but in science we tend to use the units meters per second. Now, this comes from the units of the values in the equation. So the units of speed are the units of the distance divided by the units of the time. Now, in physics we tend to have distance in meters and time in seconds, so therefore the unit of speed is the unit of the distance divided by the unit of the time, so it's meters per second. Now, there's nothing wrong with units of miles per hour or kilometers per hour, but then we're not using the standard units for distance and time, so we don't tend to use those in science. Now, this equation will work out the average speed of an object. Now, if we have a constant acceleration and an object starting from rest, 0 meters per second, the final speed the object will be travelling at is double the average speed you've calculated. That's because the average speed is the middle value of speed for the journey. Because if we had the start of the journey at 0 meters per second and the final speed at the end of the journey, the average value sits dead in the middle. So to find the final speed, you multiply your average speed by 2. Now, if an object is moving along a straight line, the distance travelled can be represented by a distance time graph. That's where you plot the distance on the vertical axis and the time on the horizontal. Now, the speed of the object can be calculated from the gradient of the distance time graph. Now, the gradient of a line is the change in the y value divided by the change in the x value. So in this instance, it's the change in distance divided by the change in time. Now, when calculating your gradient, you've always got to draw your gradient triangle on your graph because it shows what values you're using, but you've also got to make sure to make your gradient triangle as large as possible because this gives the greater range of values, so it's a more reliable result. But this method can only be used if an object has a constant speed, i.e. the line that you've drawn is straight. Now, this is one of the only graphs where you've got to join the plots and not draw a line of best fit because the graph is plotting the journey of the object. It's not looking for a general trend, which is the purpose of a line of best fit. So just remember those key concepts as we now move forward. Now, if an object is changing speed, i.e. it's accelerating or decelerating, the line of the distance time graph will be curving. So in this instance, our line is starting to curve upwards, so this shows us our object must be accelerating. Now, if an object's accelerating or decelerating, its speed can be determined by drawing a tangent and then measuring the gradient of the distance time graph at that particular time. Now, a tangent is a straight line that touches a curve at a point, but if extended, doesn't cross at that particular point. So, for example, if we wanted to have a tangent at 10 seconds, such in this graph, the line which we're drawn would only touch the curve at that 10 seconds. Now, if you want to work out the gradient of your tangent, you would just work out the gradient via the same methodology as before. So you draw a gradient triangle on your tangent and do your change in y divided by your change in x. Now, these are the following potential sections you can get on a distance time graph. So if it's a straight line going upwards, it's an object moving at constant speed. If it's a flat line, the object is stationary. If it is a line curving upwards, the object is accelerating. And if it's a curving downwards, it is an object that's decelerating. Now, please note that on a distance time graph, the line can never go downwards. That's because distance is a scalar quantity. Now, distance is how far an object moves, so it can't decrease in a journey. Even if you move backwards, your distance would still go up because it's a scalar quantity, so it doesn't have a direction. Now, if you did want to have a direction on your distance, it then becomes a displacement, which technically is the distance an object moves measured in a straight line from the start point to the finish point, okay, in that particular straight line. So it's a vector quantity. Now, displacement can go down. So if you go forwards and then backwards, you would increase your distance but decrease your displacement. So if a distance time graph shows a line going downwards or is in fact negative, it's not a distance time graph, it's a displacement time graph. So those are the different sections of your distance time graph. Now, when we've been looking at speed, we can also consider something called velocity. Now, the velocity of an object is its speed in a given direction. So velocity is a vector quantity. So it's a rate of change in the displacement of an object, because displacement is now incorporating the distance, which is required for a vector quantity. So velocity is the change in displacement over the change in time, and we can represent the direction by a positive or a negative sign. So to compare that, speed is not a vector, it's in fact a scalar quantity. It's the rate in change in the distance of an object, so it's the change in distance over the change in time, and it doesn't have a direction, so it's always a positive value. So that means velocity is a much more useful quantity than speed because it contains extra information. So it contains that information regarding direction. Now that's really useful in this situation because imagine we have two cars travelling at 30 and 31 meters per second and they collide head on. Now if they're colliding head on, one of the particular cars must be travelling in an opposite direction. So we denote this in physics by giving one of them a minus sign. Now, it doesn't make a difference which value we give a negative sign, but let's just say the one on the right is a negative. So therefore, if we say one has a velocity of 30 meters per second, and one has a velocity of minus 31 meters per second, that gives us a difference in velocity of 61 meters per second. But it would only be 1 meter per second if we were considering speed, but this is why head-on collisions are very dangerous, because there's a large difference in the values because one of them is in a different direction, so it's a negative sign. So we can work it through like that. However, if two cars collide and they're traveling in the same direction, so one car goes into the back of another car, okay, it's a slight nudge and not as dangerous as a head-on collision. That's because the difference in velocity is small. Because if they're both traveling in the same direction, they're going to have the same sign, either plus or minus. So therefore, the difference now is only 1 meter per second. So as a result, is not as dangerous a collision. So when we consider the direction of the quantity, it gives us a lot more useful information to apply to a situation. So to clarify, velocity is the speed of an object with a direction. Okay, or we consider it the change in displacement. Now, because it has a direction, it must be a vector, and we illustrate the direction with either a plus or a minus. Now, you can actually decide which direction is positive and negative, but they've got to be opposites of each other. So if we said up was plus, down would be negative. So in this situation, if we wanted to keep the direction consistent, we might say right is positive and left is negative. But you could also quite as easily say that left is positive and right is negative, or we could say that up is negative and down is positive. Okay, it's just as long as you keep your notation consistent, you are fine. Now, if an object is moving in a circle, then it can have a constant speed, but it must have a change in velocity. Because velocity is a speed in a given direction, so if it's moving in a circle, it has to be changing direction, as shown in the diagram. This means if it's changing direction, it has to be changing velocity, because velocity is a speed and a direction. So therefore, we would say if we've got a change in velocity, that leads to an acceleration. So, just to clarify what we've learnt in this particular lesson, distance is how far an object moves, but it doesn't involve a direction, so it's a scalar quantity. Now, displacement includes both the distance an object moves and the direction of that straight line travel is carried out, so therefore displacement is a vector quantity. Now, speed is a scalar because it doesn't involve direction, but speeds of objects rarely stay constant. Now, the typical values for walking are 1.5 meters per second. The typical average speed of someone running is 3 meters per second, and the typical average speed of someone cycling is 6 meters per second. Now, this value varies, it doesn't stay constant, because it can be changed by your age, the terrain you're on, the fitness you have, or the distance you've already travelled, but also the speed of sound can vary, and the speed of wind can also vary. Now, distance travelled is speed times by time, or we can say speed equals distance over time. And the velocity of an object is its speed in a given direction, which makes it a vector quantity. Now, motion in a circle involves constant speed but change in velocity. And if you've got a distance time graph, we can represent the speed of an object moving in a straight line, because we calculate from the gradient of the distance time graph. Now, if an object's accelerating, the speed we can work out can be determined by drawing a tangent to the curve and measuring the gradient of that tangent. So in today's lesson, hopefully we can describe what speed is, what velocity is, what distance is, and what displacement is. We can understand how to interpret a distance time graph, and we can retrieve information from looking at a distance time graph. I hope you found this lesson very, very useful, and have a lovely day.